Hi there, welcome to your lesson on definite integrals with substitution. Let's flash back real quick and remind ourselves of the rules of integration we should know. These are the rules we've seen in recent lessons. We have the power rule, we have the rule about 1 over x being ln x, integral of e to the x, and then the integrals with sine and cosine. These are all things we've looked at in detail in the previous lessons, but just reminding you, these are the things we're going to use in this lesson as well. Okay, now let's go back and talk about what an indefinite integral is versus a definite integral. This is an example of an indefinite integral. When we take that integral, we get something like this. All right, we always add the c because when we have no bounds to integration, that means there's no number here, no number here, then we end up with something like this, and we have to put plus c because there are infinite possible functions that you could have begun with to end up with this one here. And that's what we've been doing recently. But now let's look at what a definite integral is. A definite integral looks like this. So notice we have the same integral here. I put the same function in there, but now there's these bounds to the integration. So when we have the bounds, it is called a definite integral because we can get a single number answer. We're not just looking for a function, we're looking for actually a numerical answer. And here's how we do it. So we take the integral just like we did here. Here's the same integral. Notice the c is now no longer here, and then we put the boundaries here, 0 and 3. The 0 and 3 we see here are here. And if you remember, the process for definite integrals for solving these is you substitute 3 in here, and then you subtract the same thing with 0 substituted in it. So it looks like this. The 3 goes in here, minus, and then the 0 goes in there, and that. And then the result of that is our answer to the definite integral here. All right, so that's a definite integral. Let's apply that now. Well, let's go back to the t-shirt we saw in the opening slide. This is a definite integral. I see the boundaries here, 2 and 3. So solve it. What is the age that this t-shirt is advertising? And by the way, I'll tell you, it's bigger age than you perhaps, smaller age than mine, and I'm going to tell you from experience, it's a good age. All right, let's see if you can figure it out. Now let's check our work. So there's the integral we're given. So we take the integral, there's the integral of 3x squared plus 4x plus 1. That can be simplified a little bit further, like this, and there's our boundaries, 2 and 3. So here's with the 3 substituted in here, minus here's that 2 substituted in there, and the age we get is the great age of 30. So I hope you're able to figure that out. That's a pretty basic definite integral kind of problem, but just warming ourselves up for some tougher problems to come. So let's keep going. All right, let's try this one. We have this function here, and we're finding the integral from 0 to pi over 6. Okay, let's break this down. It says find the definite integral and then verify using your GDC. So at the end, we'll grab our calculators and see if our answer makes sense. Okay, so here's the work to begin. There's that. I pulled the 3 out because having the 3 out there, when we have integrals, we can take that coefficient out like that. Then we take an integral of sine x, which is cos x. And it's negative cos x, so there's that negative there. Then 0 to pi over 6 are our boundaries. Put pi over 6 into here, cos of pi over 6 minus cosine of 0. What's cosine of pi over 6? See if you can remind yourself back to your trigonometry knowledge or thinking of the unit circle. All right, this is exciting. Here comes the unit circle. So there we have it. We spin an angle of 30 degrees, pi over 6. We get this triangle here. We know this side is 1 over 2 in a 30, 60, 90 triangle, and this side is root 3 over 2. And when we're talking about cosine, we're looking for the x value, so root 3 over 2. So here we have negative 3 times root 3 over 2 minus cosine of 0, because when that 0 was put in there, we have cosine of 0. And cosine of 0, when there's no angle, the cosine value is 1, because we know it's this length here. So there we have that. Simplify that a little bit, and we have this. So convert that now to a decimal. So grab your calculator now, change this into a decimal value, and we get this value here. Okay, now we're going to confirm it's further on our calculator. Do you remember how to find integrals on your calculator? Well, we press math and then 9. So let's take a look at where that is. I think I have my calculator ready here. Here's the calculator. We're going to press on here, and then the math button, and then number 9. I think I have to go down here a little bit. Number 9, there it is. Function integral, enter. Oh, that's not right. Second, quit. Math and number 9. Let's try again. There it is. Okay. And that brings us to this. And we can enter a definite integral. So we can actually enter this integral right here. Try it now. You should practice doing that on a calculator. You're going to enter the bounds. You're going to put your function here, sine x. And then you can put x here at the end. And you should get the same answer we see here. Confirm you can do that. Okay, next one. So we have this function here, or this integral. It's a definite integral now with boundaries 0 to 1. Let's find the definite integral value. Okay, this is one of the ones where we need to do substitution. So I notice that 6x is the derivative of this. So I'm setting this equal to u. Then the derivative of that, du dx, is 6x. Now I can take these values and substitute them back into my integral. So we're recapping our integration by substitution here. So I substituted back in. So notice we have u cubed, this thing cubed, and then du dxx. Notice what I put here. This is important. These boundaries where for this function when it's in terms of x. So that's what I'm putting here, when x is 0 and when x is 1. Because now my variable in the integral has changed to u. So one thing, and I'm going to show you this now, this is an important skill here with these, we're going to change the boundaries so that they apply to our new u function. And the way you do that is you go back to where you made your substitution, here, and you say when x is 0, if you made x 0 here, what would u be? So let's check. When x is 0, this thing, when we put 0 in here, we get 1. So that means our new boundary here will be 1. And what about when x is 1? What happens when x is 1? What does this become? Okay, when x is 1, all of this is 4. So we can rewrite this with these new boundaries for the u function. And the boundaries are now 1 to 4. Instead of 0 to 1, because those apply to the x function. All right, so now in terms of u, we have the new boundaries, we have this. We take the integral, which is a 1 over 4 u to the 4, and we apply those boundaries 1 to 4. So you put 4 in here, and then minus 1 put into here. So you calculate it like this. 4 put into here becomes 64. 1 put into here is 1/4. 64 minus 1/4, we have our answer. It is 63.75. Now taking that answer, we're going to confirm on the calculator. But before that, let me just show you one more thing. That if you insisted on using the original function, you could have. Notice when we did all this in the substitution here, we kept it as u. We never went back to changing u to what it was here. We just kept it as u and solved it like that, which is completely fine since we changed the boundaries. But however, you can, of course, when you get to this point, put the u value back in here. So that's what we did here. Look, that u, the substitution we made is put back in, and now the boundaries were changed back to the boundaries that we had when we had x in the beginning. So that will produce the same answer that does, and that's really important to note here. You'll get the same answer both ways, and it's your choice which way you go. But often, keeping it in the u form with the substitution made is easier, because that u is usually an easier substitution than putting your x function back in there. It has a little bit more going on. But again, you'll get the same answer. Okay, now you should check on your calculator once more. Try using that math button and then the integral on either, you can do it on the original, and confirm that when you punch in this integral using the calculator, you get the same values you get here. Okay, great problem. Pause if you need to. There's a lot going on there, but you should be very familiar with all of it. Okay, next, let's try this one. So now it's getting a little more complex. We see cosine and sine here, and we see these boundaries on our definite integral. So try a similar process here, where you do a substitution. This is definitely one that requires substitution. And then you're going to change the boundaries because of the substitution. Let's see where you go with this one. And now let's check our work. So I set u equal to sine x, because here we have sine squared x, or sine x squared, so I made u sine x. Therefore, du over dx is cosine x. That's the derivative of sine x. So I see cosine x here, I see sine. I can make a substitution now. So let's do that. Here is my substitution made into there. Here's sine squared x, so that's like u squared, and that's what I have here. Then the cosine x has been replaced by du dx right here. Notice I wrote the boundaries like this again, because those boundaries were for x, for the function in terms of x. So I wrote x equals that, x equals that. Now we're going to adjust our boundaries. So you are going to use this equation equation where you made the substitution, you're going to put those x values in there and you're going to see what you get and change the boundaries. So try that now. Okay, when you put pi over 4 in there, so when x equals pi over 4, then sine of pi over 4 equals root 2 over 2. Again, you can use a unit circle to confirm that. Pi over 4 is 45 degrees, and when we have a 45, 45, 90 triangle, the y value, because sine is y, is root 2 over 2. Okay, now what happens when x is pi over 2? Okay, when x is pi over 2, sine of pi over 2 is 1, because pi over 2 is 90, and at 90 degrees the y value is 1. So now we have changed our boundaries here, and we can rewrite the integral like this, from root 2 over 2 to 1. And that is now our boundaries in terms of u. So we don't need to write x anymore. We could put u equals, but anyway, it's in terms of u now. So it looks like this. Now let's find the definite integral. So the integral of that is 1/3 u to the third power. And here's our boundaries again. Okay, now that we have our integral and the boundaries here, we can substitute 1 in there, and then minus root 2 over 2 substituted in there. That will give us this, 1/3 when 1 is put in there, minus root 2 over 12 when root 2 over 2 is substituted in here. Double check your work with the fractions carefully. And that, what decimal does that produce? Okay, the decimal answer to that is this. So that's the first time we've had to use our calculator. And now we're going to verify further in just a moment. But first, let's double check again. When we kept this in U form, we were able to put those boundaries in and calculate the value. But of course, again, you have the option of substituting back in there. So instead of U, you could have put the sine x back in there, and you would have this. And now the boundaries again are changed to the original boundaries when the function or the integral was in terms of x. So that's what we have here, the original boundaries. If you calculated this by substituting this in and subtracting this with this substituted in, you would get the same answer as we have here. I think maybe one time it's worth checking that. Maybe take a moment, pause, and try this definite integral, solve it, and just confirm that it gives you the same answer that we got here. All right, but we can also verify in our calculator. If you do, again, the math and the integral function, you can punch all this in here, and it should produce the exact same answers there. Again, take a moment to practice that and confirm. Okay, let's try this one out. Notice it says find the exact value of this. That means no calculator. All right, this should be able to be, everything should be done here without a calculator. Try it out. Okay, let's check our work. There's the integral, there's the boundaries. Then you plug that in here. Then you substitute that in there, subtract those two. Going a little further, using your knowledge of trig or maybe the unit circle, 5 pi over 3 is negative root 3 over 2 for sine, and then sine of pi over 6 is 1/2. So you have this, and that works out to this here, simplified a little bit. Hope that worked out for you. This is a really good combination of so many things you've learned. Trigonometry, integrals, even some derivatives in the background. So this is a really good problem. Hope that worked out for you. Let's try one more. So try this one here. This one will need substitution. Okay, and let's check your work. No calculator again. Here is a substitution you can make. That becomes this right here. Then the boundaries, notice, changed to this. So you adjusted the boundaries because of the substitution that was made, the boundaries for u. And then the integral of that gives you this. And then definite integral, plug the values in, you get this. This is shown in just a few steps, but there's probably a lot of more work you tried along the way there. This is really important that you're starting to feel confident with these. I hope this one went okay. Let's try the next one. Okay, I have one last one for you to try. It is this one here. Give it a shot. And now let's check our work on this one too. No calculator. There's the substitution we can make here. Notice when you make the substitution, you can rewrite this like this. Notice the boundaries have been changed again because of u. So 1 and 3 were put in here to get the new boundaries. The integral of that is this with those new boundaries, and that solved gives you this. Check your work carefully. This stuff is getting pretty complex. I hope you had some success with that. There'll be a short follow-up video with a couple more problems. We'll see you soon.